Hi Chem students. Hey, this is Mrs. Cox over in C201 and I'm developing this tutorial just to help students who are maybe struggling a bit with writing and balancing chemical equations. So if you want to work through this sheet with me, I'm hoping by the end you'll be doing a lot better with this, but the couple things that you absolutely have to have when you're working on this. The first thing is a writing utensil. None of this gets done unless you actually write it yourself. The other thing you gotta have is that ion sheet. I know you have it somewhere. In fact, I think if you flip the page over that you have, you've got it right there, because we need those if we're gonna use and correctly write equations and balance them. And bear with me, this is not easy, and it is not, it takes some patience because it got multiple steps, but it's not necessarily impossible. You can do this. Just be patient and work with me here. Okay, couple big keys when you are writing balanced equations. The first thing is make sure you cross your charges on compounds. Compounds aren't elements. If it's an element, it's on the regular old periodic table and we don't have to do any charges. But if it's a compound, you gotta cross your charges. You gotta look them up here and cross them down. And we'll do examples of that. You gotta look for the HNOF7. That might sound really like gibberish to you, but I'll explain in a second what it is. And the last thing you gotta do is you have to balance that chemical equation. If it's not balanced, if you don't have the same number on each side, on the reactants and the products, you are violating the law of conservation of matter, which is a major physics law, and you don't wanna do that. So let's just work through some examples, and I think that's probably the best way for you to see exactly kind of like what to do on these. Okay, I always tell my students the first thing you do, if you have a highlighter or if you have a pen or whatever, find the chemically kind of sounding things, the things that sound like chemicals, and highlight them or circle them. So if you look at A, what are the chemically sounding things? Well, how about hydrogen? That's a chemical. Plus oxygen. Oh, well, oxygen, that's a chemical. Yield water. And I know water doesn't sound like a chemical, but that's what it is. So now that we have that, now we know what we have to write in actual formula form. Okay, so now let's start writing. Hydrogen. How do we write hydrogen? Okay, well, hydrogen, look on the periodic table, is H. Oh, but wait a second. Okay. Hydrogen is one of these things where I call the HNOF7. The HNOF7 are a set of elements that they are needy, clingy elements. They cannot ever be by themselves because otherwise they start eating everything. And so they always have to have a friend. And so these guys always have to be 2. That's called diatomic, but they're always going to be 7. Now, HNOF7, what is that? Okay, well, what I mean by that, hydrogen, nitrogen, oxygen, fluorine, and then down, chlorine, bromine, iodide. H, NOF, 7, kind of looks like a 7. HNOF7. So circle those on your table. If you have to write one of these by themselves, you always have to give it a pair because otherwise it's not going to be happy. It has to have 2. So let's look at our next. Okay, hydrogen is H2 plus, right, just a plus. Oxygen. Oh, wait a second. Oxygen was just one of those. That's just plain old. I know it says oxide, but that's when it's combined with something. When it's by itself, it's just oxygen. And it's part of the HNOF7. So when it's by itself, you have to write it with 2. Yield water. You guys know that. H2O. All right, next step. Are we balanced? Do we have the same number of atoms on each side? No, because we have 2 on the left-hand side and we've only got 1 on the right-hand side. How do we fix this? We fix it just like we do in math class. We use coefficients. So we're going to put a number in the front that multiplies all the way through the molecule. And so what number are we going to need to put here in order to get 2 oxygens? Right, a 2. Oh, but what does that mean now? Not only do we have 2 oxygens, we've got 2 times 2 is 4 hydrogens. We only got 2 on this side. How do we make that into 4? Yes. Put a 2 right there. So now we have 2 times 2 is 4 hydrogens, 2 times 2 is 4 hydrogens, 2 oxygens, and 2 oxygens. So that all checks out and we're done. Yeah, there's a lot of steps to it, but again, they're all doable if you just take your time and just go step by step. Okay, let's look at the next one. What are the chemically things? Nitrogen plus hydrogen and ammonia. That's that smelly stuff that's kind of in cleaners. It can really smell bad, and you can actually just, it's awful on the lungs if you have concentrated stuff. But now let's write about it. How do we represent nitrogen? N. But wait, that's the N in the HNOF7. So we have to, it's by itself, 2. Plus hydrogen. That's the H in the HNOF7. So we have to put a 2. Yields ammonia. I give that to you. It's just NH3. All right. Now, next step. Are we balanced? No, we've got 2, we got 1 nitrogen here, and we've got 2 here. So how are we going to make that work? Oh, let's put a 2 here. Wait, that 2 goes all the way through. So how many hydrogens do I have now? 2 times 3 is 6, right? Can I make this into 6 hydrogens? Heck yeah, I can. 3 times 2 is 6. So that one is all done. We've got 2 nitrogens, 6 hydrogens. 2 times 3 is 6 hydrogens. So that one is all set. Okay, C. Let's do C. Chemically things. What are we going to circle or highlight? Aluminum bromide plus chlorine yield aluminum chloride and bromine. That's a lot to write, but we can do it. Okay, we've got aluminum bromide. Al. Bromide is Br. But wait, is this an element or a compound? Yeah, it's a compound, and whenever we write a compound, we have to check our charges and cross them down. What I mean by that is, let's look up aluminum. It's a +3. Let's look up our bromide. It's a -1. So again, we cross the charges down. Whatever is in the number of the superscript becomes the number on the opposite subscript. Now ones, do we write them? Nah, we don't have to worry about that. So it's just AlBr3. All right, so that's how you write that one. Plus chlorine. Where's chlorine again? Oh, chlorine is right here. Oh, it's one of these that we circled. Yes, I know it says chloride, but on the regular periodic table it's chlorine. And in this case it's by itself, so we have got to Cl2 because it's part of the HNOF7. Okay, so we got that. Yield aluminum chloride. Al, chloride is Cl right here. But wait, that's a compound, so what do we got to check? Our charges. We already said aluminum's a +3. Chloride is a -1. So what do we do? Yeah, that's AlCl3 because you crossed your charges down. And bromine. Okay, bromine, bromide. But remember, this is when it's in a compound form, but when it's a regular plain old element on the periodic table, it's bromine. And is that part of the HNOF7? Yes, it is. So we don't write just Br. We got to write Br2 because it's part of the HNOF7. Okay? Are we done with C yet? Let's look at this. Okay, aluminums are okay, 1 and 1. But we got 3 here and 2 here. That's not cool. So what do we have to do? We got to balance it. Now, can we ever make 3 go into 2 or 2 into 3? Well, no, we can't. So you have to find the least common multiple of each. And so we're going to do what? Least common multiple of 3 and 2 is 6. So you need to make 6 on each side. How do we make 6 here? Yep, multiply it by 3. How do we make 6 bromides here? Multiply it by 2. Oh, but wait, now we have 2 aluminums, so we're going to have to pull a 2 over here. And now we have 2 times 3 is 6 chlorines. How do we make this into 6 chlorines? We put a 3 right here. So now it's all balanced and it checks out. Okay, so what I'd like you to try to do, I want you to go ahead and try to do D, E, F, G, and H. Take your time, follow, make sure, highlight the chemically things, write in your pluses and yields, cross your charges, watch your HNOF7 to make sure you have 2 of them, like hydrogen, oxygen, nitrogen, and make sure you balance it at the end. Again, I know it's tedious and I know it's a slow process, but it's one of these things where it's super important in chemistry. It's one of the basic things that we do in chemistry, and I want to make sure that you guys can get this. So go through this and then check the key. There's just going to be a key posted in your room. See how you did, and then say awesome, okay, and help me. And I'm going to check with Ms. Miller later to see how you guys did with this tutorial and see if it helped or not. I like to have feedback to see if this ever helps students when I make these. So make sure you let her know whether you think this helped or whether you thought that this was absolutely worthless waste of my time. Trust, I can take criticism. It's okay. All right, sorry it's a little shaky. My stand is a little shaky, but I had to do this quickly. So, all right, good luck and work through this, and I hope you do great.